And so to continue a look at alkene reactions, let's look at the alkene reaction with a halogen like chlorine gas. So of course we have the cycloalkene here, which is our nucleophile for the reaction, and the chlorine is playing the role of the electrophile. Basically, the chlorine to chlorine bond can become polarized, sending those electrons in the bond to one end of the bond, making one atom electron deficient and one atom electron enriched. It's the electron deficient atom on the near side which is the important part, because that's ready to receive electrons from the nucleophile, that double bond and the alkene being electron rich. So a chemical bond forms by breaking that pi bond as the electrons reach out to grab that chlorine atom. As that chemical bond forms, to keep the octet for the chlorine, the existing chlorine to chlorine bond has to break, that has to give, and so that gives us the first stage of a reaction. This slow step of the reaction, as we produce that carbocation intermediate, it's a tertiary carbocation because the carbon with a positive charge has 1, 2, 3 carbon neighbours around it, and through the inductive effect it can draw electrons from those sigma bonds towards it to offset that positive charge. Now for the next step of the reaction, we can show a resonance structure, as that chlorine can actually form a new chemical bond to that carbocation atom and form this second resonance structure with this chloronium ion bridge in the molecule. And between the two structures, it explains the actual final product which is being produced. First structure explains why this chloride kicking around in solution attacks at this carbon here to form a new chemical bond. Of course, as that bond forms, to keep the octet, the existing bond has to break. And the second resonance structure here explains why the chloride attacks from the underside of the molecule. This big fat chlorine atom on the top prevents the chloride from attacking from the same side, which would be syn addition. It's actually going to be anti-addition from the lower side of the cyclic ring. So the reaction continues with a relatively fast step to produce a product which has anti-addition across the double bond. So we're getting exclusively the trans product for the reaction of the two halogens on opposite sides of the carbon to carbon ring. And of course our reaction is both regioselective and stereoselective. Regioselective because when the chemical reaction starts, the chlorine is attaching to the side which has more hydrogen, following Markovnikov's rule. The reaction is also stereoselective because we're forming exclusively the trans product of the two chlorines on opposite sides of the ring.